countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Good evening, teachers, parents, and all the wonderful students. Welcome to Pusat Academy YouTuber, Bermula Percuma Selamanya Percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let's begin our section by reciting a prayer for Muslim. The non-Muslim may pray according to your own religions. Let me introduce myself. I'm Teacher Kong from College Matrikulasi Perak, the moderator of the day. We at Pusat Tuisyen Academy YouTuber will provide with you a free online classes. Let's take this opportunity to do your revision. So, are you ready? Let me introduce our teachers for today's lesson. We have Teacher Tang from College Matrikulasi Selangor. We are now live on Teacher Tang's channel. Please support her channel by clicking subscribe now. The topic of today's lesson is ionization energy. And together with us, we also have Cikgu Shannon from College Matrikulasi Pulau Pinang, who is control host, in charge ensure the smoothness of our lesson on technical support, and Teacher Vivi Lau from Pusat Tingkatan 6, SMK Tinggi Klang, as observer to ensure the smoothness of our lesson. So, before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use the chat section wisely. Number 2, regarding certificate link, the link will be given at the end of our section. Please use eDidik account when you fill in your particular. And make sure to listen the passcode given by the presenter or moderator by the end of the lesson or from time to time. And fill in the form within the time limit, which is 30 minutes. Okay, so now please pay attention. I will announce the first 3 passcode of the day, which are A60, A60. So, without further ado, let's welcome Teacher Tang. Hi, Teacher Tang. I'm mute, right?
Sorry about that. So I forgot to unmute myself. Okay, so I'm Teacher Tan. So I'm from College Matrikulasi Selangor. So I have 8 years of experience teaching chemistry. So together with me in the pre-U chemistry team, we have Teacher Vivi Lau, me, Cikgu Shannon, Cikgu Mawar, and Teacher Kon. So all of us are led by Cikgu Shannon, our leader. So also we have the pre-U mathematics team led by Teacher In, and also biology pre-U team led by Cikgu Faiza, and also physics pre-U team led by Cikgu Rosmaya, and the accounts and economics team led by Madam Fizi. So now we move on to my topic for today. So today I continue from Teacher Vivi Lau last week. So I will continue on ionization's energy part. So what is ionization's energy? So ionization's energy, so first ionization's energy refer to the minimum energy required to remove 1 mole of electrons completely from 1 mole of gaseous atoms to form 1 mole of unipositive charged gaseous ion. So from this definition, basically it refers to 1 mole of gaseous atom, for example, atom X. Okay, so and then require certain amount of energy, so to remove 1 mole of electron from this gaseous atom X, and the amount of energy that is needed to remove this 1 mole of electrons from 1 mole of gaseous atom X is what we call as first ionization energy of atom X. And after 1 mole of electron is being removed from 1 mole of gaseous atom, then it will form 1 mole of positive 1 gaseous ion of X. So that is the definition for first ionization energy. Basically, it's the minimum energy required to remove 1 mole of electron from 1 mole of gaseous atom in order to form 1 mole of positive 1 gaseous ion. Okay, and then what is second ionization energy? Second ionization energy refer to minimum energy required to remove 1 mole of electrons from 1 mole of unipositive charged gaseous ion to form 1 mole of positive 2 charged gaseous ion. So what does it mean? So after first ionization energy, we get 1 mole of positive 1 gaseous ion. So 1 mole of positive 1 gaseous ion after first ionization energy. So in second ionization energy, another 1 mole of electron is being removed from this positive 1 gaseous ion. Okay, so the energy that is needed to remove this 1 mole of electron from this 1 mole of positive 1 gaseous ion is what we call as second ionization energy. And after this 1 mole of electron is being removed from this 1 mole of positive 1 gaseous ion, we get 1 mole of positive 2 gaseous ion. So this is the definitions of second ionization energy. So it's the energy needed to remove 1 mole of electron completely from positive 1 gaseous ion in order to form 1 mole of positive 2 gaseous ion. Okay, so with this definition, then now we move on to look at question 1. So can you tell me which chemical equations represent the third ionization energy of magnesium? So you can give your answer in the live chat. So which of the chemical equation represent the third ionization energy of magnesium? Must remember, so first ionization energy, so it is from the gaseous atom. So we remove 1 mole of electron. Okay, so first ionization energy is the energy that is needed to remove 1 mole of electron from 1 mole of gaseous atom in order to form unipositive charge gaseous ion. So that is the first ionization energy. So after first ionization energy, we get this. So we use this for second ionization energy. So any answer from students?
Yes, teacher Tang, there are
so what's your answer?
Jinsin and Tim Wong, which is B.
Okay, very good. The answer is B. Okay, because after first ionization energy, we get Mg positive 1. So second ionization energy, it is from Mg positive 1. Remove another mole of electron, so we get Mg positive 2 after second ionization energy. So therefore, in the third ionization energy, okay, so it will remove 1 mole of electron from Mg2 plus ion in the gaseous state in order to produce Mg3 plus ion in the gaseous state. Okay, very good. So now we move on to look at what are the factors affecting ionization's energy. So basically, ionization's energy indicate telling us how easy an electron is being removed from an atom or ion. Okay, so basically how easy an electron is being removed from an atom or ion depends on the attractive forces of the nucleus on the remaining electrons or outermost shell electrons. Okay, and the second factor is the screening effect, okay, by the inner shell electrons. Okay, so with these two ideas, then we can conclude that basically the first ionization's energy of an element is influenced by three factors. So the first factor is the effective nuclear charge. Okay, we know that effective nuclear charge basically is the net attractive forces experienced by the outermost shell's electron after taking into account the attractive forces by the nucleus and also the shielding effect or screening effect by the inner shell electrons. Okay, and the second factor is the shielding effect or screening effect. Okay, so this is basically referred to the repulsion by the inner shell electron. So means that more inner shell electron, greater the repulsion. So then the attractions of the nucleus on the outermost shell's electron will be weaker because repulsion higher. So higher attractions will be weaker. So the atomic size will be bigger. Okay, so basically three factors: effective nuclear charge, shielding effect or screening effect, and the third one is the atomic size. Okay, so we shall look at across a period first. So which factor is the dominating factor when come to across a period? So we know that, so this is period 3, I use period 3 as an example. We know that as across period 3, from sodium to argon, the proton number increases. Okay, so proton number here representing nuclear charge. Okay, so but then the shielding effect, so shielding effect, we look at the inner shell electron. So inner shell electron remains the same. Okay, so remains constant. So means that the shielding effect remain constant. Okay, because the number of inner shell electrons of all the elements across period 3 are 10. So the one that I highlight here, so these are the inner shell electrons. So they are all 10 for period 3 elements. So, and then with the increase in the proton number, with shielding effect remain constant, therefore Z, effective nuclear charge, increases as across a period. Okay, so this will cause, okay, so okay, let me conclude first. Okay, so when across a period, what increase? Proton number increase. Okay, so proton number increase with shielding effect remain constant, causes the effective nuclear charge to increase. So we are going to see how it is going to affect the first ionization's energy of elements across a period. Okay, with increase in effective nuclear charge. So basically, we need to know across a period, the dominating factor in affecting the first ionization's energy of elements is effective nuclear charge. Okay, as across a period, so just now we have seen for period 3, proton number increases. So, but then the shielding effect remain constant. This will cause the effective nuclear charge to increase. Okay, and then when effective nuclear charge increase, means that now the attraction of nucleus on the outermost shell's electrons becomes stronger. When the attractions of the nucleus on the outermost shell's electron becomes stronger, the distance between the nucleus and the outermost shell's electron become closer, and this causes element across a period to have decrease in atomic radii. Across a period, atomic radii become smaller. Okay, so when atomic radii becomes smaller, means that now we need more energy to remove. So more energy to remove 1 mole of electron. Okay, and this causes the as across a period, the first ionization's energy of element increases. Okay, because atomic radii across a period becomes smaller due to increase in the effective nuclear charge as the proton number increases as across a period. Then how about when going down a group? So for example, here I use group 1. So as going down group 1, we can see that the number of inner shell electrons, so this is 2. So the number of inner shell's electron increases. Okay, so lithium only 1 shell, 1 inner shell. Sodium have 2 inner shell filled with electrons, while potassium have 3 inner shell filled with electrons. So as going down the group, we know that the number of inner shell filled with electrons increases. So when the number of inner shell filled with electrons increases, means that now the shielding effect will increase as well. Because remember, the number of inner shell filled with electron is going to affect the shielding effect. When the number of inner shell filled with electrons increases, means that now the shielding effect increases as going down a group. Okay, so shielding effect refers to the repulsion of the inner shell electron on the outermost shell's electron. So basically, when going down the group, shielding effect will be the dominating factor affecting the atomic radii and also the first ionization's energy of an element. So we can see that shielding effect increases, okay, as going down the group, causes the atomic radii to increase as well as going down the group. So this will cause less energy needed to remove an electron. Okay, therefore, as going down the group, the first ionization's energy of an element decreases. Okay, so we shall see the factors, the explanations again. So when going down the group, again, shielding effect is the dominating factor. Why? Because as going down the group, the number of shell filled with electrons increases. Okay, this causes the effective nuclear charge to increase as well. When going down the group, the number of shell filled with electrons increases, and this causes a screening effect or shielding effect to increase as well. So when the shielding effect increases, this will cause the attraction of the nucleus on the outermost shell's electron become weaker. So when the attractions become weaker, then the distance between the nucleus and the outermost shell's electron become further. Therefore, the atomic radii become larger as going down the group. So this will cause energy needed to remove an electron decreases as going down the group, and the first ionization's energy decreases as going down the group. Okay, so you just need to remember, when going down the group, number of shell filled with electrons increases, so shielding effect increases. So when shielding effect increases, so the atomic radii become larger, so the energy needed to remove an electron decreases. Therefore, first ionization's energy decreases. So now we move on to look at question number 2. So question number 2, arrange the following elements in increasing order of first ionization's energy. So to answer this question, first thing you need to ask yourself is whether this is across a period or going down a group. So for lithium, proton number is 3, oxygen 8, fluorine 9. Okay, and all these 3 elements are period 2 elements. So they are same period. So same period means that across a period. So if across a period, so which one will be the dominating factor, effective nuclear charge or shielding effect? So it will be the effective nuclear charge. So if effective nuclear charge, we need to look at the proton number. Okay, we need to look at the proton number. Okay, so from lithium to fluorine, we can see that their proton number increases. So means that ZeV increases. So ZeV refer to the net attraction. So means that attraction of the nucleus on the outermost shell electron becomes stronger. So when attraction becomes stronger, means that now the distance will be shorter. Okay, so the distance will be shorter. So the atomic radii decreases. So atomic radii decreases from lithium, oxygen to fluorine. So when atomic radii decreases, means that they become smaller. So when become smaller, easier or harder to remove an electron. So if harder, that means that more energy is needed to remove an electron. So therefore, the first ionization's energy will be higher. So I give you a lot of hints already. So any answer from the students? So
okay, Justine answer 2A. Question number 2A.
Okay, question number 2A. Okay, so the answer is correct. Okay, so because atomic radii decreases, so becomes smaller, so means that harder to remove an electron from lithium, oxygens to fluorine, so even harder. So therefore, fluorine will have the highest first ionization's energy, and the lithium lowest. Okay, good. So now we move on to look at question number 3. So we want to arrange the following element in descending order of first ionization's energy. So means that the larger until the smallest. Okay, so again, now by looking at the element, we need to ask ourselves whether they are in the same period or same group. Like this one, they are group 17 element, they are all halogen, so definitely is going down the group. Okay, so when going down the group, remember the number of shells filled with electrons increases. Okay, so when number of shells filled with electrons increases, means that now the shielding effect increases as going down a group. Okay, from chlorine to bromine. So this is going down the group. So number of shell filled with electron increases, so the shielding effect increases. So means that when the shielding effect increases, so shielding effect is the repulsion. So means that the attractions will become weaker. So when the attractions become weaker, means that the distance further. When distance further, means that the atomic radii increases as going down the group. So when size become larger, so means that easier to remove an electron. When easier to remove an electron, means that the first ionization's energy will be lower. So I give enough hints already. So any answer from the students for question number 3? Any answer from the question from the students for question number 3?
Okay, there is no answer yet. Please wait for a while, Teacher Tang, and check your answer.
Okay, sure. Okay, atomic radii increases from fluorine to bromine. So when the size become when the size become bigger, so it will be easier to remove an electron. The first electron easier to be removed.
Okay. Answer from Jisin 3A and Andy Wong say, is it B?
Oh, the answer is B. Okay, descending order. Descending order. Okay, so descending order. Okay, so you see, for bromine, it is the bigger size. So if the bigger size means that require the least energy to remove the first electron. The least energy means that the first ionization's energy would be the lowest. Okay, so fluorine smallest means that hardest to remove the first electron. So if hardest to remove means that need the most amount of energy. So if required the most amount of energy means that the first ionization's energy is the highest. Okay? So that is for the first ionization's energy of element across a period and also going down a group. So now we move on to look at anomalous case. Okay, so generally across a period, the first ionization's energy increases. The first ionization's energy increases because remember, as across a period, proton number increases, so causes effective nuclear charge to increase, so attraction stronger, so therefore atomic radii decreases, so smaller size, so size becomes smaller, so means that harder to remove the first electron. So harder to remove means that across a period, the first ionization's energy should increase. However, across period 2 and period 3, we see anomalous case whereby group 2 and group 13 element, we are expecting group 13 element to have higher first ionization's energy. But in real situation, no. The group 13 element has lower first ionization's energy than the group 2 element. So beside that, between group 15 and group 16 element for period 2 and period 3, also you see the same thing. We are expecting group 16 element to have higher first ionization's energy. But then, that is not the case. Group 15 element has higher first ionization's energy than the group 16 element. So why? So we shall look at group 2 and group 13 element first. Okay, so I use boron and beryllium as the example. So group 2 element beryllium, group 13 element boron. Okay, so group 2 element beryllium has higher first ionization's energy than group 13 element boron. So why? It is because, okay, if we look at beryllium, so we are removing electron from the 2s subshell. And this 2s subshell is fully filled. So fully filled 2s subshell, basically it is more stable. So when it is more stable, means that more energy needed to remove an electron from beryllium atom. Okay, while for group 13 element boron, so the first electron is removed from the partially filled 2p subshell. And partially filled 2p subshell is less stable. So when it is less stable, means that less energy needed to remove an electron from the 2p subshell. So therefore, boron, because remove electron from the 2s subshell, which is more stable, require more energy. Therefore, beryllium will have the higher first ionization energy from boron. Okay, because in beryllium, we remove electron from the more stable, fully filled 2s subshell. Okay, therefore, more energy needed in order to remove an electron from the more stable, fully filled 2s subshell of beryllium. Okay. Besides that, we can also explain it in a way that, okay, let me draw first. Okay, so for beryllium, so this is the energy level for the subshell. So it has 1s and the 2s subshell that is filled with electron. So, okay, while for boron, it has 1s, 2s, and also 2p subshell that is filled with electron. Okay, when we talk about ionize, means that we are moving the electron to the infinity. We are moving the electron to the infinity. Okay, we are moving the electron to the infinity. Can you see that 2s subshell? Okay, so 2s subshell. Okay, so electron in the 2s subshell require this much of energy in order to be removed to the infinity. While for the 2p subshell, because it is at higher energy level, less energy is needed to remove an electron from the 2p subshell to the infinity. Okay, so because of that, beryllium will have higher first ionization energy than boron, because the 2s subshell located at lower energy level. So when located at lower energy level, more energy is needed to remove one electron or to bring one electron to the infinity compared to the electron in the 2p subshell of boron. So 2p subshell located at higher energy level, so means that less energy is needed to bring one electron in boron to the infinity. Okay, so this is the second way to explain it. So 2p subshell located at higher energy level. So when located at higher energy level, so means that it is more well shielded than the 2s subshell. So you see 2p subshell located at higher energy level than the 2s subshell. So therefore, 2p subshell required less energy. Okay, less energy is needed to remove an electron from the 2p subshell compared to remove an electron from the 2s subshell. So the same explanation goes to...
Hi, Teacher Tang.
Yeah?
Shall we stop for a while for advertisement?
Oh, yeah, sure.
Okay.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, let's continue our lesson with Teacher Tang.
Okay, thank you. The same explanations go to period 3 element for group 2 and group 13 element. Okay, so now we move on to look at group 15 and group 16 element. So remember the anomalous case, not just between group 2 and group 13, but also happen between group 15 and group 16. So we shall look at why first ionization's energy for group 15 element is higher than the group 16 element. So the example that I use here is nitrogen and oxygen from period 2. So for nitrogen, it is group 15 element, and oxygen group 16 element. So to remove an electron from nitrogen, it is removed from the 2p subshell, and this 2p subshell is half filled. And half filled subshell is more stable. So if more stable means that more energy needed to remove an electron from the half-filled 2p subshell of nitrogen. While for oxygen, the 2p subshell is partially filled. So partially filled 2p subshell is less stable. So therefore, less energy needed to remove an electron from the 2p subshell. Okay, so another reason is we can see that in oxygen, okay, group 16 element, there is one of the orbital in the 2p subshell having electron pairing out. Okay, and electron pairing out increase the electrostatic repulsion, increase the electron-electron repulsion in the 2p subshell. Okay, when increase the electron-electron repulsion in the 2p subshell increases, means that now it is less stable. So if less stable means that less energy needed to remove an electron from the 2p subshell of oxygen. Okay, so the same thing goes for period 3 element between group 15 phosphorus and group 16 element of period 3. Okay, so the explanations is the same. So group 15 phosphorus higher first ionization's energy than group 16 sulfur due to the same reason. Okay. So now we move on to look at successive ionization's energy. Okay. So successive ionization's energy, okay, tell us. So first, what is successive ionization's energy? So successive ionization's energy refer to the ionization's energy that is continuously being put into a species in order to remove the electrons from the species. Like for example, sodium atom. So sodium atom having 11 electrons. Okay, so the energy that put in to remove the first electron is first ionization's energy, and the energy that is being put in to remove the second electron is the second ionization's energy, and the energy that is put in to remove the third electron is third ionization's energy. And this first, second, third ionization's energy basically are the successive ionization's energy. So the ionization's energy yang berterusan that is being put in to remove the electron continuously from a species. Okay, and then the value of ionization's energy basically telling us how hard it is to remove an electron. So larger is the ionization's energy value. So larger means that harder to remove an electron. Okay, so and we can see that from sodium. Okay, we can see that for sodium atom. Okay, so the successive ionization's energy value increases, become bigger. The successive ionization's energy value becomes bigger, means that it is getting harder to remove the next electron. So why is it is getting harder to remove an electron? It is because, okay, so successive ionization's energy of element increases, means that harder to remove the next electron. So why? It is because as the electron continuously being removed, but the number of protons of the species still remain constant. So like for example, the sodium just now, always having 11 proton inside the nucleus. Doesn't matter how much electron, how many electrons of the sodium being removed, inside the atom, inside the nucleus, will always having 11 proton. Okay, so means that the number of proton inside the nucleus of sodium remains constant. Okay, even though the number of electrons around it keep on decreasing, but the proton number inside the sodium still remain constant. So this will cause the effective nuclear charge of the species to increase. Okay, so as electron continuously being removed, okay, so means that the shielding effect decreases, but the proton number remains the same, so nuclear charge remains the same. So this will cause the effective nuclear charge of the species to increase. So means that now the attractions of the nucleus on the remaining electrons will become stronger. So means that the nucleus will attract the remaining electrons stronger. So the distance between the nucleus and the remaining electron will become closer. Therefore, more energy is needed to remove the next electron. Or we can say that the successive ionization energy of an element increases because electrons are continuously being removed from an increasingly more positive ion. Okay, since the effective nuclear charge increases. So now we move on to look at what is the uses of successive ionizations energy data. Okay, basically from the successive ionizations energy data, we can determine the position of an element in the periodic table. Okay, so in the periodic table, so we can determine the position of an element in the periodic table. So from successive ionizations energy data, okay, how can we determine the positions of an element in the periodic table? So first method, we can plot a graph. Okay, we can plot a graph. Okay, so what graph to plot? We can plot log to the base of 10 ionizations energy versus number of electrons removed graph. Okay, and then from the graph, we can determine how many energy levels involved to determine the period. And then we can write the valence electronic configuration, okay, to determine the group and also the block of an element. And then from there, we can determine the position of the element in the periodic table. Okay, so for example, so I use this successive ionizations energy data for sodium to plot log to the base of 10 ionizations energy versus number of electrons removed graph. Okay, so this is number of electrons removed graph. Okay, and then from this graph, can you see that there are 3 energy levels? Okay, so there are 3 energy levels. Okay, so which one is, okay, so basically from this graph, we can see that there are 3 energy levels. So these 3 energy levels indicating that there are 3 shells filled with electrons in this element. Okay, so the energy level indicating how many shells filled with electron. So for this element, 3 energy level. So therefore having 3 shells filled with electrons. Okay, and then from this graph, okay, so how do we, from this graph, we know that there are 3 energy levels. So which one is n equals to, so which one is, okay, let me, n equals to 1, which one is n equals to 2, which one is n equals to 3. Okay, so let me, okay, so which one is n equals to 1? A, B, or C? Okay, so basically, the n equals to 1 is the innermost shell electrons. Okay, so it's the innermost shell. Okay, so means that the shell that is nearest to the nucleus. And then so here there are three shell filled with electron. So the n equals to 3 would be the outermost shell. Okay, so from this graph, I label it ABC. Students, now I want you to tell me which one, ABC, is the outermost shell. Okay, so which one is the outermost shell? Okay, any answer from the student?
Answer from Team Wong, A.
A. Okay, so the answer, outermost shell, is C. Okay, so outermost shell is the shell that is furthest from the nucleus. Is the shell that is furthest from the nucleus. So this element, so I call it X, so sodium just now. So sodium having 3 shell filled with electrons. So which one is the outermost shell? Why is it C is the outermost shell? Okay, it is because C is the furthest away from the nucleus. So the attractions of nucleus on the outermost shell's electron is the weakest. So if the attraction is the weakest, means that lowest energy. So lowest energy needed to remove the outermost shell's electron. So you need the least energy to remove the electron in the outermost shell. So ABC, can you see that C having the lowest energy, having the lowest level of energy. So if it has the lowest level of energy, means that that is the outermost shell. Okay, compared to B and C, lowest energy level means that that is the electrons in the outermost shell. Okay, so in the outermost shell, so here this is outermost shell and only having 1 dot here, so means that only having 1 electron. Okay, so only have 1 electron in the outermost shell. Okay, and then so basically this is the first electron that is being removed. So this is the first electron that is being removed. So it is removed from the outermost shell. Okay, and this is the second electron being removed. Third, fourth, fifth, sixth, 7, 8, 9, 10, and 11. Okay, so this first electron is removed from the outermost shell's electron. That's why it is at the lowest energy level. Okay, and then in between the first and the second electron, can you see that there is a drastic increase in ionization's energy? Okay, so there is a drastic increase in ionization's energy between, so first electron, so first ionization's energy, so second electron, second ionization's energy. So there is a drastic increase between first and the second ionization's energy. So what does this mean? So means that start from the second electron, it is being removed from the inner shell. Okay, so we can see from the diagram that I draw here. So this is the first ionization's energy, remove the electron from the outermost shell. Okay, and then second electron, it is removed from the inner shell. Okay, inner shell is closer to the nucleus, so attraction is stronger, means that you need to put in a lot more energy to remove the second electron. Okay, so that's why there is a drastic increase between the first and the second ionization's energy, because started from the second electron, we start to remove the electrons from the inner shell. Okay, inner shell. Okay, so from this, Okay, so second electron start to remove from the inner shell. Therefore, in the outermost shell, we can conclude that only having one electron, in the outermost shell. So another way to look at it is you just need to look at where is the drastic increase. Okay, so it's between first and the second ionization energy. So the smaller one, indicating the valence electron, So, and then second means that the second electron started to remove from the inner shell. And then in between second to the 9th electron, can you see that their increase in ionization energy is only a little bit increase. Okay, only a little bit increase. So what does this imply? So basically it tells us that the second to the 9th electron, their increase in ionization energy only a bit. Means that from second to the 9th electron, they are being removed from the same shell, same energy level or same shell, same inner shell. Okay, so from second to 9, there are 8 electrons. So there are 8 electrons. Therefore, in the second energy level, so there are 8 electrons. Okay, and then between the 9th and the 10th electron, there is another drastic increase. So means that start from the 10th electron, it is being removed from another inner shell. Okay, and that is the innermost shell. Okay, so we can see that from the 9th and the 10th electron, there is another drastic increase. So means that start from the 10th electron, it is being removed from another inner shell. Okay, so here is actually the innermost shell. Okay, and then between the 10 and 11 electron, can you see that again, the increase in ionization energy is just a bit. Okay, so means that these 10 and 11 electrons, they are from the same shell, from the same innermost shell. Okay, so from this, okay, so the first energy level, the innermost shell, okay, so having 2 electrons. Okay, so from this, we then, okay, so there are, so here we know that there are 3 shells filled with electrons. Therefore, this element is period 3 element. Okay, because having 3 shells filled with electrons. Okay, and then this element consists of 1 valence electron. So 1 valence electron, so you have learned if 1 valence electron, the valence electronic configuration must be 3s1. So 3 here because it is in period 3. So period 3, 3 shell filled with electron. Therefore, the highest principal quantum number is n equals to 3. Therefore, the valence electronic configuration is 3s1. And this 1 here because 1 valence electron. Okay, so from the valence electronic configuration, we can determine that it is s block element because valence electron go into the s subshell. So s block element and then group 1 element because 1 valence electron. If the question asks you to write the electronic configuration, you can start with 1s2 until 3s1. So 1s2, 2s2, 2p6, 3s1. Okay, so now we move on to look at, so this is if they give you full set of ionization energy, then you can plot the graph, log to the base of 10 ionization energy versus number of electron removed graph to determine the positions of an element in the periodic table. So if they don't give you a full set of data, then you need to use calculation to determine the positions of the element in the periodic table. Okay, so for calculation, you will not know how many shells filled with electron because they do not give you full set of data. You won't know the period of the element. Okay, So if they do not give you full set of data, you can do calculation. So what calculations you can do is you calculating the ratio. So how do you calculate the ratio? Is the next ionization's energy divided with the previous ionization's energy. So IE2 divided by IE1, IE2 divided by IE1. So you get 3.14. Okay, and then IE3 divided by IE2. So IE3 divided by IE2. So you get 1.51. So means that 2745 divided by 1817, you get 1.51. And then IE4 divided by the one before IE3. So 11577 divided by 2745. So you get this ratio. From the ratio, okay, you need to find, so step number 1, you calculate the ratio. Okay, so step number 2, you determine the highest ratio. So where is the highest ratio? So it is between IE3 to IE4, IE3 to IE4. Okay, so highest ratio is IE3 to IE4. Basically means that drastic increase occurs between IE3 to IE4. So from this drastic increase, then you can determine the number of valence electron. So just now I already taught you, just now is IE1, drastic increase occur between IE1 to IE2. So means that one valence electron. So if drastic increase occur between IE3 to IE4, can you tell me this element having how many valence electron? 3 or 4? So I give you 30 seconds. Can you tell me 3 valence electron or 4 valence electron? So just now, if IE1 to IE2, 1 valence electron. So now drastic increase occur between IE3 to IE4. So telling me 3 or 4 valence electron. This element having 3 or 4 valence electron.
Okay, Teacher Tang, there are answers from Huiru, Jasin Chai, and Tim Wong. All the answer is 3.
Okay, very good. Means that there are 3 valence electron. We'll choose the smaller one. Okay, so means that the third electron is still removed from the outermost shell. Third electron still removed from the outermost shell, and then started from the fourth electron, only you remove from the inner shell. Okay, so after we get the valence electron, then we can write the valence electronic configuration. Okay, so for successive ionizations energy, you can only deduce for S and P block element. Okay, so if there are 3 valence electron, how should we write the valence electronic configuration? We do not know the period, so we write it as N. Okay, so remember, so 3 valence electron, so 2 must go to S subshell and another one must go to P subshell. Okay, 2 go to S subshell, another one go to P subshell. So by looking at this valence electronic configuration, can you tell me this element belongs to which block? Belongs to which block? Okay, I give you 10 seconds. Which block? Any answer from the students? Which block? NS2MP1. Yeah, so which block? NS2MP1.
Okay, there are answers from Huiru and Jasin, P block.
Okay, very good. P block. Okay, NS2MP1, so must be P block. So can you tell me which group does this element belongs to? P block, 3 valence electron, so which group? Okay, I'll give you 10 seconds as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any answer from the students?
Yeah, from Peru, group 13.
Okay, very good. Okay, must remember p block element from group 13 until group 18. So 3 valence electron must be group 13 elements. Okay, so now shall we look at the explanation? So drastic increase occurs between IE3 to IE4. So means that it has 3 valence electron. So valence electronic configuration NS2 and P1. So p block element group 13. And the 4th element is the one started to be removed from the inner shell, which is closer to the nucleus and has more stable electronic configuration. That's why more energy is needed to remove the 4th electrons. Okay, so I think okay, time's up already. Okay, so not enough time. So these are the video that I made related to ionization's energy. So you can go and have a look. Okay, and then that's it from me for today's class. Thank you.
Okay, we've got Grace. We are done with today's section. We have learned a lot from Teacher Tang about ionization energy. Congratulations to those who are able to follow our section from the beginning till the end. And thank you very much, Teacher Tang, for such an interesting lesson. Before I provide the last class code, right, please check the chat box for the certificate link. Please off the live chat button and click subscribe button if you haven't do so. This is to show your appreciation to Teacher Tang for giving a free lesson today. So now I would like to announce the last 2 passcodes, which are 3, 1. 3, 1. Okay. So don't forget to click the bell button too, so you won't miss out any new video or live class from Teacher Tang. If you like today's lesson, okay, please click like and share it to your social media friends. Let's share the knowledge you received today with them. Sharing is caring. Okay, when you have finished, type down in the chat section. Then I will give you, okay, I give already the passcode. So hope you can get all the number or alphabet. Okay, once again, I would like to thank you, Teacher Tang, for the interesting lesson. Thank you also, Teacher Bibi Lau and Sir Shannon for being with us today. I think that's all for now. See you all in another section. Please remember, stay home. Goodbye, everyone. See you all again next week. Bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.